Okay, so we're going to look at some compound inequalities. Compound just means two things put together. And so if you look at this first example, you're going to notice that I have two inequality signs. So we have two inequalities put together, which makes a compound. I'm going to solve these two to figure out if I have an and or an or graph. And you'll notice real quick that or graphs always have the word or in it, and and graphs don't. Okay? So this should be an and graph, but we're going to solve it just to make sure. Now, at first you might get kind of freaked out by having two symbols or two signs. It's pretty easy. Basically, all you got to do is hide part of it. So I want to hide this sign right here. When you hide that, notice how you get this inequality expression or equation right there. Then I want to go over here and I want to hide this side, and notice how I get this inequality. So I have my two inequalities, and I'm going to write the word and in between because that's the two problems I have to solve. Okay. Notice how I took 3 plus 8x with both of them because that's what's in the middle, that's what they share. Then I just solve them both like just two normal inequalities. Remember, you want to always get your x's on the left side. So I'm actually going to subtract my 8x. That's going to give me a negative 4x minus 1 less than or equal to 3. Then I'm going to add that one to get negative 4x less than or equal to 4. Divide by my coefficient of negative 4. Remember this rule. Anytime your coefficient is a negative number, you have to flip this inequality symbol. And then I get a negative 1 for an answer. You got to flip that symbol because this coefficient is negative. Over here, again, getting my x's on the left side, I want to subtract 7x. So I get 3 plus 1x less than or equal to 9. Subtract 3. I get your 1x less than or equal to 6. Divide by that 1. I don't flip this time because 1's positive. And so I get this. So I've got two answers. Okay. So first of all, let's do our set. You got two answers. This gets a little bit trickier. Okay, I've got my x as my variable. But I've got two answers I got to put together. Okay. So I got to think about it. My answers are anything that is greater than or equal to negative 1 and less than or equal to 6. So I'm going to put x in the middle. I put my negative 1 here and my 6 here. Just putting it in like I would on a number line. And so I got to use the same sign. Well, I can look at and see that this x and this 6 is written the same way. So I'm going to bring that symbol down. And which means I keep the same symbol here. If you read this, it says x is less than or equal to 6. Read it this way, x is greater than or equal to negative 1. So this is my two answers put together in a compound notation. To graph this, we put our numbers over here in the number line. Negative 1 and a 6. Give me any number you want to in between them. I don't care what you use. Okay. Decide if you want points or holes or if they're different. At negative 1, I want a point. At 6, I want a point. And we got to figure out what numbers satisfy this. What numbers are less than 6 but bigger than negative 1? So if I look at my 2, 2 is less than 6 and 2 is bigger than negative 1, which means all the numbers in between are my actual answer. So an and graph looks like a dumbbell. So this is your and graph. Okay? Your integral notation for an and graph won't have any infinities. You don't have any arrow shaded, so you don't have any infinity signs. If you read this from left to right, you started shading right here at negative 1. You stop shading at 6. You've got a point at negative 1, and point means bracket. A point at 6, and that means bracket. So this is your notation. Any number in between negative 1 and 6, including negative 1 and 6, can be your answer. Okay, so let's look at an OR problem. Number 2 is an OR problem. See how an OR problem has the word OR in between, and you already have your two inequalities separated for you. So you just solve both inequalities. Be careful with your signs. Get your x's on the left side. So I want to subtract x. And I get 3 minus 2x is less than negative 7. Subtract 3. So I get negative 2x is less than negative 10. I'm going to divide by negative 2. Remember, if that coefficient is a negative number, you have to flip your inequality. So you get x is greater than 5. Over here, again, subtract your 8x, because you want x's on the left side. You get negative 2x minus 5 greater than negative 9. Add that 5. So you get negative 2x greater than negative 4. Divide by a negative coefficient. So again, flip your sign. Here you go. So we got two answers. We got x is bigger than 5 and x is less than 2. So if I go to graph this, I've got 2, I've got 5, and I've got something in between. At 2 I have a whole because it's not equal to. At 5 I have a whole because it's not equal to. And we got to fight the urge to try to put it together automatically. You have to read what it says. Numbers less than 2. Well, 3 is not less than 2, so numbers less than 2 actually will go this way. Greater than 5. Numbers greater than 5, well, that's not 3. It would actually go this way. So an OR graph breaks apart. So your notation, your set notation for an OR graph, there's nothing fancy about it. You actually write out your two answers, the smallest one first, put the word OR in there, and the biggest one. There's nothing fancy like I had up here with the AND graph. OR graph simply says OR. The graph breaks apart. Notice how there's two sections here. Because there's two sections here, you're going to have two interval notations. If I start reading this section, this arrow is negative infinity, and I stop at 2. We know we're going to have parenthesis around infinity. 2 is a whole, so I'm going to have a parenthesis here. I'm going to pair that up with, so I'm going to union that with this graph. So this graph starts at 5 and ends at positive infinity. 5 is a whole, so parenthesis. Infinity is always parentheses, so this would be your notation. Two pieces of a graph gets two interval notations. Let's do one more, and then we'll stop with this video. Okay, this one, there's no words in here, so it's going to be an AND graph again. Remember, you see two symbols, you're going to hide one symbol, and that's your first inequality that you're going to write down. Then you're going to take and hide the other symbol, and this is the second inequality that you're going to write down. Remember, this middle section of 1 plus 10b, it goes with both parts, the whole thing, okay? Then we just solve both of these, and we see what we get. Again, get your b's or your variables on the left side, so subtract 10b. So I get negative 3b plus 4 less than 1. Subtract 4. Negative 3b less than negative 3. Divide by a negative coefficient. Flip your symbol. Over here, minus 9b from both sides. Subtract your 1. Divide by 1. I don't flip this time because that 1 was positive. And so notice I have two answers. Greater than 1, less than 7. It's going to be an AND graph because there were no words. Okay, I put my variable slash. Remember, b goes in the middle, my smallest number, then my biggest number. Now look at the one that's written the same way. B's on the left, 7's on the right. Here it is. B's on the left, 7's on the right. Take that symbol, and use it. Notice this symbol kept the equal to because this one had it. This one does not have the equal to because this one didn't have it. Okay, so when I graph over here, I've got 1. Let me fix this so we can see it. Hold on. There we go. I've got 1 and then 7. Give me a number in between. Don't care what it is. 1 I want a whole because 1 is not equal to. 7 I want a point because 7 is equal to. Then read your notation. I want numbers that are bigger than 1 and less than 7. Well, hey, 3 is bigger than 1 and 3 is less than 7, which is why I know I have the graph in between. It's another dumbbell, okay? Now, reading this for my interval notation, I start seeing the green at 1. I stop at 7. No infinities because I have no arrow shaded, okay? A whole means a parenthesis. A point means a bracket. Okay, so study your notation, study your symbols, and you should be good.